Since its inception, predicting the stock market has been a popular yet challenging task in the finance industry. The difficulty in prediction lies in the multitude of factors which can affect the value of a stock, making its time series data non-linear, highly dynamic, and seemingly random. The efficient market hypothesis alludes that the prices of stocks are always efficiently priced based on all currently available information, while the random walk theory states that the movement of the financial markets follows a random walk. These two well-known but controversial hypotheses hold the agreed conclusion of the near impossibility of predicting the stock market consistently. However, the efficient market hypothesis assumes that investors always act in a rational manner, which has been proven false through historical phenomena such as the 2008 financial crisis. Another example for this happened in 2018 when Snapchat's stock value fell by $1.3 billion because of a single tweet by celebrity Kylie Jenner. As such, utilizing sentiment data acquired through sentiment analysis might be an effective way to take advantage of inefficiencies caused by irrational investors. Sentiment analysis is a sub-area of natural language processing that focuses on the identification and extraction of opinions/sentiments of a given text input. For this project, sentiment analysis was performed on news headlines from the New York Times utilizing transfer learning model, bidirectional encoder representation from transformer, also known as BERT. When initially introduced, BERT was able to achieve state-of-the-art results for 11 different natural language processing tasks, including sentiment analysis. BERT was pre-trained using book corpus and English Wikipedia and is deeply bidirectional in its representation. Due to this, BERT will typically be a better model when compared to more traditional sentiment analysis models. Once sentiment analysis has been performed on the New York Times headlines dataset, the past 7 days average sentiment score for every single data point is calculated. Sentiment data will then be used alongside the historical adjusted close price to perform a one-day stock price forecasting. For this portion, a long short-term memory model was proposed to be used. Long short-term memory, also known as LSTM, is a type of artificial recurrent neural network that is often used for the analysis of time series data. Due to the way it was designed, LSTM is capable of learning long-term dependencies from its inputs. The input to the LSTM will be the past n days worth of adjusted close price and the 7-day average sentiment score, where n is known as the time step/window size. Through repeated testing, a window size of 10 was determined to be the ideal choice. LSTM was evaluated using mean absolute error, mean squared error, and root mean squared error matrices. The final conclusion is that the inclusion of sentiment data does improve stock price forecasting performance by a small amount, as seen by the comparison of the evaluation results on screen. With that, I end off my video. Thank you for your time.